Absolute zero is the coldest temperature we could ever have. We can't go any colder than that because atoms literally stop moving. But what about the hottest temperature? Is there a limit for how hot something could get? Since hot temperature is atoms and molecules moving really fast, some might say temperature could go on increasing until infinity, but that's not completely accurate because we know there is a theoretical limit, which is approximately 1.4 multiplied by 10 to the power of 32 Kelvin. That's 10 million billion times hotter than our sun's core. They call this the Planck temperature, and it comes from fundamental physics constants describing gravity, quantum effects, and light. For perspective, the hottest temperatures achieved on Earth are in particle colliders, creating cold gluon plasma around 5.5 trillion Kelvin. Impressive, but still incredibly colder than Planck's temperature. The core of massive stars or supernovae reach tens of billions of kelvins. The hottest known natural phenomena are events like the merger of neutron stars or extremely energetic material falling into supermassive black holes, reaching trillions of kelvins. The Big Bang itself in its very first instant, however, remains the hottest confirmed event in the universe. It may have been as hot as the Planck temperature, but it's uncertain because we lack the data to describe that era properly. If you heat a metal rod enough, it will start emitting light. At the beginning it is red, but when hotter it may become white or pale blue. This happens because when a body is hot, it emits photons, which are particles of light that also behave like waves. The distance between two peaks of this wave dictates the color. The hotter it gets, the shorter the wavelength becomes, shifting from red to blue. In physics, there is a minimal measurable distance which we can't go below. It's the most basic building block known as the Planck length. At such scales, gravity becomes incredibly strong compared to other forces. In other words, we have to treat gravity in a quantum way instead of the classical one, which we don't really know how to do yet. The hypothetical particles that might carry gravity in this quantum realm are called gravitons, but to this date they remain a theoretical prediction yet to be proven. So imagine if a body gets so incredibly hot to the point where it emits light with a wavelength equal to the Planck length. At that point, we have no idea what would happen. Would it even have a color by then? Or would something entirely new happen? We wouldn't understand its behavior because our laws of physics break down completely. It evades our understanding. So in reality, Planck temperature isn't really a proven maximum like absolute zero is a minimum. There might not be any physical law stopping energy or bodies from exceeding it, but it's like the last gate of our knowledge, the point where our current science stops working.